Welcome to the sampling distribution of sample proportions. So the idea here is we have some population with a known proportion with some attribute. So we have a population with a proportion P with some trait. And then we plan to pick a random sample of size M. I apologize for the conversation in the background. So we plan to pick a random sample of size M and study the sample proportion P hat. So we basically want to know what might we expect to find for P hat. So we are going to look at what I call the P hat distribution. I'm going to give myself a little more space, 1 moment. So we need to study the P hat distribution, which is the distribution of possible sample proportions. So anytime we study a distribution, we want to know the shape, center, and spread. So it turns out if we meet a very specific requirement, then we can assume the p hat distribution is essentially normal. So if, this is a major if n times p, so the sample size times the population proportion, and n times 1 minus p are both 10 or more, then the p hat distribution is essentially normal. So that's major. We've been studying normal distribution, so it's very useful to have a normal distribution. Again, n is the sample size. P is the population proportion. If we do not meet these requirements, then we don't know the shape well enough, and we cannot use a normal distribution as our sort of assumed shape. Next up is the center. So the mean of the p hat distribution we will label as mu for the mean, and then we will put a subscript p hat because we're talking about the p-hat distribution, is simply equal to p. Again, p is the population proportion. And then this here, we pronounce mu sub p-hat. So the formula for the mean is very simple. And then we have spread. We will do the standard deviation. Of the p-hat distribution. Which is also referred to as the standard error. We're studying the p-hat distribution. P is the actual proportion. So the center of the distribution is the actual proportion. P-hat is what a sample told us. So since we are using the sample proportions to estimate the population proportion, the sample proportion's distance from the mean essentially is the error in our estimate, hence standard error instead of standard deviation, but they mean the same thing. We use sigma sub p-hat, sigma for standard deviation, p-hat because it is the p-hat distribution, is equal to the square root of p times 1 minus p divided by n. So again, this symbol here is sigma sub p-hat. So let's go ahead and just do an example. It is thought that 26% of US college students have dependent children. You plan to pick a random sample of 50 US college students. What are the shape, center, and spread of the sampling distribution? So here we are looking at 26% of US college students have dependent children. This is essentially our known fact. This is our population proportion. So we have p is equal to 0.26 if we use decimal format instead of percent format. We are picking a random sample of 50 students. So that is our sample size. N equals 50. And we want to know the shape, center, and spread of our distribution. So we are looking at the p-hat distribution. First thing we will look at is the shape. So for shape, we needed to check n times p and n times 1 minus p and check that those were each 10 or more. So n times p, we are looking at 50 times 0.26, which is 13. And n times 1 minus p, we are looking at 50 times 1 minus 0.26, or 50 times 0.74. And this is 37. So in both cases, These are both 10 or more. So we meet the requirement we need. So that means that the p-hat distribution is essentially normal in this case. So the distribution is essentially normal. Next up, we have center. Again, for center, we are just looking at mu sub p hat is precisely p, and p is 0.26. So we have mu sub p hat is 0.26. And this is the center of our distribution. For spread, we have sigma sub p hat is equal to the square root of p times 1 minus p divided by n. Or sigma sub p hat is equal to the square root of 0.26 times 1 minus 0.26 divided by 50. And if we do this, so from here, working with the top first, we're looking at the square root of 0.1924 divided by 50. Then that becomes the square root of 0.003848. Taking that square root, we then get 0.062 approximately. So our standard deviation or our standard error is sigma sub p hat equals 0.062. So this is the shape, center, and spread of our distribution.